good morning, fifth graders. Welcome to the lesson 3. This is the last lesson for the evaluation of the quiz. So we're going to start with a new topic. So the topic is related with electricity, and the name of the topic is the electromagnetic connection. The magnetic connection. What is the electromagnetic spectrum? This is the question. So we are going to read a short story, some biographies of some scientists that start in the story in the beginning of the electromagnetism. That this is the word electromagnetism. So we are going to start reading in 1820. Danish physicist Hans Christian Ørsted made an interesting observation when he placed a compass near a wire carrying an electrical current. The compass needle moved toward the wire. As soon as he turned the current off, he needed point north again. Oyster saw the electricity and magnetism were related, right? But he was not sure how. 10 years later, a British physicist with the physicist Michael Faraday, proved the Oyster discovery worked in the opposite direction too. Faraday put a magnet near a wire attached to a meter. The meter showed that an electrical current moved through the wire, even though it wasn't connected to any electrical source. The magnet was causing the electrons to flow inside the wire. This is the picture of the first physicist, Hans Christian. Hans or Christians Oyster, right? And the second is this picture is about Michael Faraday, the second one that continue with the Oyster or Michael theory 10 years later. So Faraday also showed the electricity flowing in one wire will cause a current to move in another wire placed next to it. Some kind of invisible, right, invisible energy was radiating from magnets and the electrified wires. This energy could create more electricity and magnetism. Faraday had discovered electromagnetic fields. We are going to learn this word, electromagnetic fields, like lights glowing from a light bulb, right? The one that you have in your house, or heat flowing from a hot sidewalk. Electromagnetic fields surround magnet and electrical currents. Okay, so we have two. We have the electromagnetic fields and the one with magnets, right? And the other with flowing currents, right? So one is about magnets and the other is about electrical currents. Another British physicist with the name James Clerk Maxwell suggests that this electromagnetic energy was shaped like waves. Maxwell soon realized that light, which he knew also moved like a wave, was a kind of electromagnetic energy as well. So I want to show you the picture. He was James Clerk Maxwell, right? The one that suggests that electromagnetic energy was shaped like waves, right? So we're going to continue and finish the reading. The atom structure, right? We're going to talk about atoms. The atom's structure, right, was unknown. Nobody know it, right? In Maxwell's time. So he realized. So he did not know exactly what was happening. When electrons flow through a wire, their movements send out waves of energy or radiation. What is radiation, people? For example, in your house, you can have radiation when you turn on your cell phone and you have Wi-Fi. You can cause radiation. When you use your microwave oven, you can make radiation. Radiation, some scientists said that radiation is killing the people and produce cancer. Some antennas of Claro, Tigo, the big ones of the mountains, of the mount, sorry, make radiation. So this radiation is not good for our bodies, our brains, and our parts of our, for example, our heart or our brain. So you have radiation in your cell phone, and some people have three or four cell phones, one laptop, two laptops, especially actually in your house. So these waves create an electromagnetic field which acts like a magnet and can create an electrical current. For example, when a magnet is placed near a wire made of a good conductor. You're going to look for this word in the dictionary, wire. You're going to look for it and wave those two words. Okay, you're going to investigate. So, of a good conductor, like copper, energy from a magnet's field causes electrons. Remember, electrons is electricity, right? Negative and proton are positive. Don't confuse. To move in the wire, it creates an electrical current. Very good. An example. Look, this is a big magnet that produces the magnet or magnetic field that can take the car. Magnetism has proven to be one of the science's most important discoveries. Light, heat, microwaves, radio waves, and X-rays. With the X-rays in the hospitals, the doctors can see your bones, right? X-rays is the same, magnetic fields. So, all waves of electromagnetic energy, electromagnetism may even be the link connecting in everything in the universe. Oh my God. This topic is very important. The electromagnetism or the magnetic fields is the most important, one of the most important discoveries. So we are going to make the classwork and we are going to choose the correct answers. Circle the letters of the best answers to each question below. Number 1, electricity and magnetism were invented by James Clerk Maxwell, are related to one another. Both move through wires, work together to create electrons. Electricity and magnetism were invented by James Clerk Maxwell. Remember, are related to one another. Both move through wires. I think this is the answer. Electromagnetism is, you have to pronounce the M after the S. It's not easy for me, sorry. Electromagnetism, practice, is a form of energy, light, atoms, all of the above. Can produce energy, lights, and atoms. I think is the letter D, all of the above, because remember, it's talking about the bulb, right? The light bulb. What is light? Energy in the form of a wave, magnetism, electricity, electrons moving through space. What is light? Energy in the form of a wave, magnetism, electricity, or electrons moving through space. What is light? Okay. Next. Electromagnetic fields surround magnets, electrical currents, waves, both A and B. A and B. Magnets, I think it's waves. Waves, right? Write your answer on the lines below. Name two forms of electromagnetic energy. Name two forms of electromagnetic energy. You can use the same of the magnets, right? And you can investigate for other way to make electromagnetic energy. Okay, in China, for example, in Japan, the trains are work it work with magnetism, right? The train has magnets in the road, the train roads have magnets, so the trains go like flying with the waves that produce the two magnets between. The trains go faster than electricity or than gasoline or than other way. So the magnetism or magnetic fields are important because actually are in everywhere. I told you, in the microwaves, in the cell phones. So we don't see it, but it's a kind of energy too that is very useful and important actually. So this is the classwork. See you in the next class. Make the classworks. In the next class we are going to have a meet. I think it's tomorrow, right? We're going to have a meet. So in the meet we are going to discuss the questions. Thank you so much. Bye bye.